Hello my dear little champs, I welcome all of you to India's first animated live tuition. I welcome everyone to 90 plus my tuition app family. I hope all of you are ready over there for a brand new session. Let's get back with a lot of energy guys. I want energy from you all. You all should be there energetic, right? So imagine if you guys are just sitting over there, yes sir, please go ahead. No, I want that energy from you guys. Please stay active over there. Please do reach out if you have any concerns, queries and all. You can drop your queries in the chat box, and also you can raise your hands and ask me directly. And also if there are new students, what you have to do, please contact our academic counselor team. So what they'll be doing, they'll be providing you with the links which you have missed, links of the live sessions which you have missed. So for that, please do contact them. You should have a genuine reason, okay? It's not something like always you can skip the session and you can get the links. No, not at all. So please do reach out guys. I hope everyone has revised all the portions which we covered in the previous session. Guys, did you do it? Studied? Fine. So in the previous session we were discussing about the image formation in the case of convex mirrors, right? So in the case of concave mirrors we have learned. Now in the previous session we have learned the image formation in the case of convex mirror as well. So concave mirror and convex mirror is done. So what next? So before we go, can I ask questions? Everyone ready? Revise the concepts? Fine. So I'll be asking to Bhagat Suresh. Hi Bhagat Suresh. Hi Bhagat Suresh, are you there? Yes, please do unmute yourself. Bhagat is like, yes sir, I'm here.
Yes sir.
So Bhagat, have you revised the concepts? Ready with it?
Yes sir.
Fine. So Bhagat, please do let me know, if the object is kept at infinity, where will we get the image? In the case of a convex mirror. Bhagat is thinking, oh god. Object.
Sir, can you repeat the question?
If the object is kept at infinity, in the case of a convex mirror, where will we get the image? Image formation by convex mirrors. If we have the object at infinity in the case of a convex mirror. Yes. Convex mirror.
Image will be at
Image will be?
convex. Oh, it is convex. It will be after the convex mirror. It will be pointing towards us.
It will be towards F.
Yeah, it will be parallel to the principal.
Okay, it appear to fall towards F, right? So in front of the mirror or behind the mirror? In front of the mirror or behind the mirror?
In front of them. It will appear to be at F behind the mirror.
Behind the mirror?
Parallel to the principal axis.
Okay, fine. So the incident ray, if we are considering it as parallel to the principal axis, how will it appear to be? It will appear to pass through the focus, right? The actual ray will reflect away since convex mirrors are diverging mirrors. Clear? Fine. So what about the nature of the image? Will it be a virtual and erect or real and inverted? What do you think?
It will be virtual and erect.
It will be virtual and erect, right? In the case of convex mirrors, at infinity, between infinity and the pole of the mirror, in all these cases, we'll get the nature of the image as virtual and erect. In the first case, if the object is exactly at infinity, the position of the image will be at the focus behind the mirror. Okay? Now, if the position of the image object is between infinity and the pole of the mirror, the position will be between P and F1 behind the mirror. What is F1? Behind the mirror, right? Got it? Clear?
Yes.
Okay. We can mark it as P and F itself. Don't get confused with it. Now, the size of the image will be diminished in this case, and the first case, the size will be highly diminished or point size. Very good, Bhagat. You can mute yourself. Fine. Now, whom should I ask next? So, guys, today we have Jayasudha ma'am as our support tutor. Jayasudha ma'am, say hi to our students.
Hi students.
Guys, were you able to hear? No, right? Much louder.
Hi students, can you hear me?
You heard it, guys? Fine.
Yes.
So I'll be asking Devananda. Hi Devananda, please do unmute yourself. So Devananda,
Hi.
did you revise
Yeah.
before we go?
Yeah, I did.
Okay. So is there any festive things happening? Any
No.
reason festivals happen at your home?
No.
I can see a festive mood on your face. Nothing, right? Easter or
No,
something?
nothing.
Nothing. Fine. So if the
Yeah.
image, yes. Go ahead.
No, I didn't say anything. You can continue.
Fine. My question is, if the image formed by a mirror for all positions of the object placed in front of it is always erect and diminished, what type of mirror is it? What do you think? Always, we are getting the image as virtual and erect. So the object is kept always in front of the mirror, and the image which we are getting is always erect and diminished, or virtual and erect.
Is it convex?
Not sure or what? In the case of convex mirror, in all the cases, we'll get the image as virtual and erect, right? And size will be always diminished, either highly diminished or just diminished. So this particular mirror will be none other than the convex mirror. Devananda, I know you knew the answer, but still you are confused. You're not thorough with it. Don't get confused. Please be thorough with it. So how you can be thorough with it? Please do learn the ray diagram. Please do learn the each cases, like if you're keeping the object over here, if you're keeping the object at this particular position. But in the case of convex mirror, you don't have to get confused, right? In all the cases, it is similar. At infinity, between infinity and the pole, in all these cases, we are getting the image as highly diminished or diminished. Nature is virtual and erect in both the cases. Easy, right? Easy. The first case at the focus. The next case between P and F. Pole and the focus. Clear? Fine. So, convex mirror always forms a virtual erect and diminished image of the object placed at any position in front of the mirror. Okay? So, the answer is none other than the convex mirror. The ray diagrams, we have learned it already. So, in the previous session, I hope you remember it. So, those who were not there, please do get the links of it. So, watch the recorded live session which you missed. Now, let's gonna go ahead with the next topic, that is, what are the features of an image obtained from a convex mirror? Any particular feature? We have learned about its nature, right? So let's go ahead with its features. So always we'll get diminished and erect image, right? In case of a convex mirror, the size of it will be always diminished, right? In both the cases, in the first case it was highly diminished, in the next case it was just diminished. So always the nature of the image will be diminished and erect. Then also one more point to add. Image distance is less than the object distance. Okay? In the case of convex mirrors, the image distance will be less than the object distance. Okay? It will appear to be closer. So guys, can you tell me an example? Have you ever seen? So very small, right? Fine. Anyways, don't worry. I'll zoom it. So guys, can you figure out what it is? What is this particular small diagram? You'll be thinking, what is this small picture? Have you noticed in the rear view mirror of your vehicle, car, or a two-wheeler, whatever? Have you noticed? Objects in the mirror are closer than they appear. Guys, how many of you have noticed? Objects in the mirror are closer than they appear. Yes, right? Fine. So image why is that? It's just because in the case of a convex mirror, image distance is less than the object distance. Okay? Image may appear to be closer, right? Now, so this is the example which we have learned, that is, objects in the mirror are closer than they appear. Okay? So, anyways, so this is a particular example in the case of the use of a convex mirror. Okay, so based on it, let's learn about the different uses of mirrors. So let's learn about the use of concave mirror and convex mirrors. So uses of mirrors. So plane mirror, you know it, right, guys? Know it, right? Everyone will be standing in front of the mirror, and yes, okay, do I look handsome? Do I look pretty, gorgeous? Okay, my hair is not good. Let me correct it. Fine. Okay, now is it fine? You guys do it, right? So what you'll do, you'll take a concave mirror and do like this. No, right? Your face will look like some extra filters added, right? For sure. But what if you are using a convex mirror? Your face will look bulged, right? Your cheeks and all will go in both ways. It will not be proper, right? So for that, what you'll be using? You'll be using plain mirror. Leonardo D'Souza is like, yeah, every day without a mirror I can't even live. In the morning, even when I wake up, no, first thing whatever I do is I go in front of a mirror and check myself. Okay, did I get something over here? Pimples coming? No, right? Fine. So guys, what we'll be doing? We'll be using a plain mirror. So check on ourselves, right? So Leora, enough. I understand it happens with everyone. So this is a particular example of a plain mirror. So every day we will be using it, right? So it's just for observing ourselves or for observing the face and all. So for all these things we'll be using the plain mirrors. In the case of a convex mirror, is used as a rear view mirror and is used as traffic safety mirrors. So this is an example for traffic safety mirrors. So have you ever seen such mirrors anywhere? So such mirrors, where can you find this? It'll be in a corner. If you can see a junction road where two roads are connecting each other. So in the corner, this particular mirror will be kept. So this will give a diverged view. Okay, so from one side itself, we'll be able to see there is another vehicle coming from the different direction or what. Okay, not in all 360 direction, just in this corner direction we'll be able to see. So if you are coming from this particular direction, we'll be able to see. We can, if there is any particular vehicle coming from the other direction, that is, it'll give a view of L-shaped view will give. Got it, guys? Just because it's a divergent mirror, right? So it'll have a diverging surface. So all these things will be properly focused in it. Focused in the sense not in the exact same size, it will be diverged. So it will give a diverged wider view. So for the wider view, we will be using convex mirrors. So and also in the case of vehicles and all, in the case of rear view mirror, we will be using convex mirrors. So guys, please do note it down. Uses of mirrors. So first thing, plain mirror you can write for observing face. You know it. So if you feel like okay, you'll forget, you can write. Or else Leora will remember always, even though she didn't write. So like this, if you guys feel like okay, I won't forget this, you don't have to write plain mirrors. And in the case of convex mirror, please do note it down. Some of you won't be thinking about the traffic safety mirror and all. Rear view mirror will be there in your mind, right? So convex mirror, the uses used as rear view mirror and used as traffic safety mirrors. Write down, guys. Can you take last slide, guys? Nothing is there in the last slide. It's just you guys looking at the mirror. Fine, plain mirrors. Everyone will be checking, right? Do I look good? Dream shake is like no sir, I don't look at the mirror. I hate mirrors and all. No, other one. Which one? What is that other one? This one? Who was that? Yes. Jessida ma'am, can you take the last slide? Who was that? Fatima, can you please raise your hand? Are you talking about this particular slide or what? Yes, fine. Fatima told me, give me a yes, then it's fine. You don't have to unmute or raise your hand. Devnanda is like, yeah, also, I also wanted this particular slide, right? Fine, please do note it down quick. No, fine. So can you show the features of a convex mirror again? Features of a convex mirror, right? What are the features of a convex mirror? These are the features of a convex mirror. What should I do? Make a new slide or what? This is not fair enough. So please do reach out if you didn't understand. What is diminished? What is erect? What is image distance is less than object distance? How is that possible? Divergent mirror, right? Direct application. Write it down, guys, quick. So guys, such one word question or one more question will be there for exams. What are the features of an image obtained from a convex mirror? Diminished, erect, image distance is less than the object distance. And also there'll be a bigger question for 3 marks and all. So along with it, what are the features of an image obtained from a convex mirror, and also give some examples of its uses. So along with it, you will be adding used as rear view mirrors, used as traffic safety mirrors. So all those examples also you should add. So if you combine these 2 points in these 2 slides, what you'll be getting? You'll be getting 3 marks for your final exams. Clear? You don't want marks? Just the concept. So everyone is confident with the concept, sir. We just need the concept. Fair enough. So guys, once you're done, we can go ahead. In building filled with parking spots, yes, building filled with parking spots, such traffic safety mirrors will be established. So that will give a particular wider view if the vehicle is coming from the other side. So an example of convex mirror slide. So could you please show examples? Yes, we are going to go ahead with it. So these are the examples of convex mirrors. Traffic safety mirrors and rear view mirror. Write it down guys, write it down, important. Use of mirrors are important. Somehow you'll get 1 mark question or 2 mark questions. Fine. Also will be checking on it. Yes. So can you show the features of a convex mirror again? Who wants a feature? I said yes. In underground parkings also. Yes, in underground parkings also. Features of a convex mirror, guys. This was the question which I asked previously or right away. Man, we got the question right away or what? Who wants the features of a convex mirror? Did it already, right? Got it? Fine. Quick guys, quick. Make notes, short notes so that you will remember. But don't be like, sir, I took screenshot, I didn't write. I'll be screenshotting you away from the meeting. You won't be sitting in my meeting, okay? If you want to attend the session, please do note it down in a physical notebook itself, mandatory. Done everyone? So once you're done, please do let me know. Let's go ahead guys. Done? Fine. So next let's go ahead with the concave mirrors. So everyone should give me, what are these pictures? So first one, second one, third one, fourth one, fifth one. So one by one we'll be asking. So Evelyn, Margaret, Figueiredo, unmute yourself. Yes, Evelyn. Yes. Evelyn, are you there? So what is this particular first example over here? So is this astronaut's helmet or what?
It is used by doctors.
Doctors, okay. So have you noticed it?
I've seen it, but I don't know. But I think ENT.
Okay, ENT is used as mirrors. So over there, you can see, you'll be able to see a convex mirror or a concave mirror.
It's a concave.
Yeah, anyways, heading is given concave mirror, so obviously it will be concave. Are you aware of it?
No,
Okay.
it isn't.
Okay. Honest answer. So over here, the first picture is a device used by doctors, so they'll be using it. So they'll be having an installation of a concave mirror. So with that, they'll be able to focus the light, or they'll be able to focus the image obtained. Okay. So I thought it was a bracelet. God, bracelet like this and convex mirror over here. For what? To look at myself or what? Not possible. So guys, the second picture will be giving the answer. So what is this, guys? Dim light and bright light, right? So for that, how can we use a concave mirror? So who was that just below Evelyn? Jaswin, right? Hi Jaswin, please do unmute yourself.
Yes, sir.
So Jaswin, the second picture, what do you think? I think it's, if you say I think it's a car, no, I'll remove you from the meeting. So Jaswin is like, sir, I think it's a car. No. So Jaswin, over here in this particular example, where can we apply the concave mirror example concept? What will we do for it?
Second one.
Second one, yes, in this picture.
Yeah.
Think about it. Where can we use a concave mirror over here? Abdullah is trying to answer. Yes, Jaswin, go ahead. Give a wild guess, it's okay. You can give the dumbest answer, completely fine. You can give a wild guess. So Jaswin is like, yeah, now I'll give it a try.
Spread the light even more.
It'll spread light even more, cause of what? So concave mirrors. So I'll help you. This is an example of a concave mirror, right? We know it anyways. As Evelyn said, it's written, so it's sure clear. So in the case of a concave mirror, is it a diverging mirror or a converging mirror? Convergent or divergent? What do you think? Concave mirrors, divergent or convergent? Divergent or convergent? Jaswin?
Divergent.
Divergent. Concave mirrors are divergent. Think about it. The rays coming into a concave mirror will split away or focus inside.
Convergent.
It's convergent, right? So, in the case of a concave mirror, we know it's a convergent mirror. So, over here in this particular example, in the case of the headlights of cars, what will happen? When the light spreads over there, because of this convergent property, so this light rays will be focused to a particular direction itself. Or else what will happen? All the light will spread all over there. So will we be able to focus the things, or will we be able to see the things in front of us, or in front of the car? It'll be tough, right? So so as to focus the light rays into a particular direction itself, we'll be using a concave mirror in the headlights of vehicles or cars. Got it, Jaswin? Focus over here.
Yes.
Okay, so Jaswin, what we'll be doing? Jaswin will be writing concave mirror, convergent mirror. Okay, concave mirror, convergent mirror. How many times, Jaswin? How many times you want?
5.
Not enough. You'll be writing it 10 times. Right away. Okay, right away. Okay, right away. Write it down. Concave mirror, convergent. Okay. Now, Abdullah Athaullah Khan.
Sir,
Yes.
Linda is asking a question. What is the correct answer for what first picture?
For what the first picture? Doctors will be using it. Got it? Yes. Abdul, please unmute Abdul. Abdul Athaullah Khan, right? Yes.
Yes.
Abdul, so over here, in this case, in the case of a torch lamp or torch light, how we can apply the case of a concave mirror, or example of a concave mirror?
Reflectors of the light, like the behind.
So inside it, or in this particular frame over here, the light rays will be reflected. Multiple reflections will be happening. So as a result, we'll get
Light. Okay.
so light won't be spreading unwantedly, right? It'll be scattering in a particular direction itself. Okay, it'll be scattering properly so that we'll get the light in a particular direction itself. So it scatters the light rays. Got it, Abdullah?
Yes.
Fine, Abdul. Okay, fine.
Yes, Abdullah.
Yeah. So who will we ask next? Sania Faisal. Hi Sania. On top, ma'am. Right here. Yes.
Yes.
Hi Sania, right?
Yes, Sania.
So Sania, over here.
Yeah, it's a contact mirror that's used to the face.
For shaving, as shaving mirrors, we'll use concave mirrors, right? Why? Why?
So
For shaving, we'll be checking out the focus, like minute parts and all, we'll be checking out, right? So for that, to get a focused output, for that we'll be using concave mirrors. Now, in the next picture, Sania, next picture. Sania Faisal, are you there? Please unmute Sania. So this particular example,
yeah, dentists.
dentists will be using it for what? What they'll be doing? They'll be checking, right, our teeth. So all the teeth, how they'll check? So all this image of multiple teeth will be focused on this small round thing right over here. So this particular instrument, dentist will be using to check out, okay, to get the converged image in that particular surface. So they'll be using concave mirrors. Fine, very good, Sanya. So these are the examples in the case of the concave mirror, guys. Please do note it down. Please do note it down. So one by one you can note down. ENT doctors use it as head mirrors. Who told it? Evelyn, right? Yeah. Fine. So ENT doctors use it as head mirrors. Now it is used in torches, used as shaving mirrors, used as dentist mirrors. So guys, please do note it down one by one. First one, ENT doctors use it as head mirrors. Examples, okay, or uses of concave mirrors. Once you're done writing, please do let me know. Can we go ahead? First example done? Fine. Unmute Mohammed. Who's that?
Muhammad Ishan Hussain.
Hi Mohammed Ishan Hussain. Unmute yourself.
Yes, sir. So what does the torch do with concave mirror?
What is the?
Torch do with the concave mirror?
The light will be scattered. Light will be scattered into a particular direction itself. Because in over here, in the case of a torch light, if you are keeping a concave mirror, all the light rays will be trying to focus to a particular point, right? So multiple concave mirrors will be there. So all these light rays will go multiple reflection when it comes from this source point. So imagine if you do not have any particular concave mirror and all, the light rays won't be focused or scattered to a particular direction. It will be scattering to unwanted directions or n number of directions. So you won't be able to see the things in front of you using a torch. Got it? So the scattering property will be made to focus into a particular direction itself using a concave mirror. Got it? So scattering will have some manners. Okay, this is how we will scatter since concave mirrors are installed. Got it? So the light rays will be converged. Fine. So over here the use of concave mirrors used in torches, used as shaving mirrors, used as dentist mirror. Please do write down. For the object placed between principal focus and pole, the image forms are enlarged and erect. In the case of concave mirror. This is the only exception, right? Do you remember, guys, in the case of concave mirror, in all the cases, it was real and inverted, right? But only in the case if the object is kept between F and P, that is the focus and pole. Only in that case, we will get the image behind the mirror as enlarged and erect. So guys, once you're done writing the uses of concave mirrors, please do let me know. So there is some additional point for you to remember. You have learned it already. Case of concave mirror, for the object placed between principal focus and pole, the image formed are enlarged and erect. This is how we can relate the concepts with the uses or examples. So guys, once you're done writing, please do let me know. Let's go ahead.
Sir, Mughal is finished. Mughal.
Okay, Mughal says that, sir, I finished. Everyone done? Give me a thumbs up. Everyone, once you're done writing, give me a thumbs up so that I can go ahead. Fine.
Yes.
Fine. How can you identify the three types of mirrors without touching them? Who will be telling me? So, Fayaz, right? Fayaz. Fayaz Ahmad, unmute. Yes, ma'am. Over there. In the middle. Yes.
Okay.
Yes. Hi, Fayaz Ahmad.
Yes, ma'am. Yes, sir.
Faiz or Fayaz? I forgot.
Yes, sir.
Fayaz, right? Okay, I'm good. I know I'm great. So, Fayaz, what do you think? How can you identify the three types of mirrors without touching them?
So we can identify the mirrors without touching them by looking at its design.
Looking at their design. So, how will it be if it in the case of a plain mirror?
So plain mirror it will be flat.
Okay, it'll have a flat surface, fine. Then in the case of a concave mirror,
Concave mirror it will be
it'll be concave mirror will be. Go ahead.
it will be in depth.
It'll be curved inwards or curved outwards.
Curved inwards.
So concave mirror will be curved inwards. Then in the case of a convex mirror,
It will be curved outwards.
it'll be curved outwards. Fine. So anyway, some of you are sharing the surface will be bulging outwards in the case of a convex mirror. Some of you are sharing, okay, it'll have a bigger size. Fine. So we'll check it. If the image form is erect, of same size and at equal distance behind the mirror as the object and is in front of the mirror, then the mirror is plane. What are we using? We are not using the physical appearance. We are using its attributes like the size, nature. Okay. In the case of a plane mirror, we'll be getting an erect image that is behind the mirror, and it'll have the same size, and it'll be having equal distance behind the mirror as in the case of object. So the distance from the object to the mirror, if it's 2 centimeter, the distance from the mirror and the image will be 2 centimeter as well. So the distance from the object and the mirror image will be 2 plus 2, 4 centimeters. That is double the distance of the object from the mirror. That is the distance from the object to the image in the case of a plane mirror, guys. So imagine if it is a plane mirror. Okay, if you're keeping the object over here, we'll get the image. We'll get the image exactly the same distance over here. So erect image, right? Same size, guys. Don't think, oh, this arrow is a little bit bigger. No, they're supposed to be the same size. This is my artistic skills. So over here you can see, imagine, first case we are keeping the object that is 2 centimeter from the plane mirror. We'll be getting the image exactly 2 centimeters away from the mirror, and we'll be getting the image over here, and the size of it will be the same. Got it? So how do you know if the distance will be exactly the same? It's the same. It is supposed to be the same, because if the distance is different, will we get the same size? Guys, do you remember in the case of concave mirror, if you're keeping the object at the center of curvature, we'll get the same size. Why? Because the object distance and the image distance was the same, right? Only in that case, we'll get exactly the same size. Got it? Who was that?
Regin.
Regin. Got it, Regin? Give me a yes if you got it, or let's raise your hand. Give me a yes in the chat box, or else raise your hand so that yes, Regin. Please do raise your hand. So Regin, in the case of a Regin, are you there? Are you listening?
Yes, sir, I can hear you.
Yeah. So Regin, in the case of a concave mirror, do you remember if you are keeping the object at the center of curvature, what will happen?
Sir, you'll get the same.
We'll get the image exactly at the center of curvature itself, right? So what will be the object distance from the mirror? It will be same as the image distance from the mirror, right?
Yes.
Got it? So in the case of a plane mirror, we know that when we are looking at the mirror, we don't see ourselves away from the distance. We are standing from the mirror, right? When we look at the mirror, do we see ourselves away? No, right? Exactly the same position, right? In the mirror, in the reflection. Just so the man, please do minimize it. Regin,
Yes, sir.
isn't it? So if we have the same size same distance over there, will we have the same size? For sure, right? In the case of a concave mirror also, we have seen that. So always, if you have the same distance from the object and the mirror, and the image and the mirror, if it's the same, if the distance is the same, and if you in that case, what will happen always? We'll get the same size, right? But in the case of a plane mirror, you know it, as in the practical examples, when you look at the mirror, do you see yourself away from you, or away from the actual object or your position, or do you see yourself very close? No, right? You see yourself at the exact same position where you're standing. If you go behind the mirror also, you'll be going behind. If you go close in the mirror also, you'll be getting closer. Got it? So in the case of a plane mirror, the distance will be the same, and similarly the size will be the same. If you're going away, our size will be reduced, right? If you're coming closer, our size will be increased. Isn't it? So it's not something like that, it's just that we are seeing our projection a little bit closer. That's it. So in this case, understood, Regin? Clear?
Yes.
Fine.
Yes, sir.
So yeah, so please do note it down, guys. If the image form is erect, of same size and at equal distance behind the mirror as the object, and it is in front of the mirror, then the mirror is plane. Now, so you got an example, right? Now, please do let me know, how will we identify a concave mirror and a convex mirror? Who will be answering? How will we identify a concave mirror and a convex mirror?
Ulrich Gerard.
Okay, Ulrich. Please do unmute Ulrich. Ulrich, are you there?
Yes, sir.
So Ulrich, do let me know, how will we identify a concave mirror likewise? So I have given you an example in the case of a plane mirror. Yeah. Let me know the features of a concave mirror.
if the image is bigger in size and erect, it's concave.
It is concave or convex?
Small. Concave. Bigger
Concave.
size and erect.
Okay, it'll be bigger in size and erect.
Yeah.
Okay.
And for convex, smaller in size and erect.
Small in size and erect. But in the case of concave mirror, we have real and inverted as well, right? Yeah, then what we'll do?
What?
In the case of concave mirrors, we have the nature of the image as real and inverted, right? We have that case as well, right? In the case of concave mirrors, did we learn it? Real and inverted are there. Only in one case we have virtual and indirect. Then how is your theory applicable? Alright. Ulrich is thinking, sir, please don't get me confused. I gave my answer. It's okay, Ulrich, nice try. So we'll check out the answers. Fine. So, yeah. Who will be answering next? Unmute Dhruv. Hi, Dhruv. Dhruv is like, sir, please don't call my name. I don't know the answer. Dhruv, do you know the answer? No, fine. So it's better not to unmute me, sir. Please don't put me in trouble. So guys, who want to answer? So we'll check out, right? We'll check out. Okay. Kaushal is focusing. Yes, hi Kaushal Raj. Kaushal is really focusing over here. Hi Kaushal.
Yes, sir.
You have a different screen in front of you, what?
Monitor, sir. It's
Yeah. I know it. You have a different monitor screen in front of you, right? Fine. So.
yes, sir.
So Kaushal.
No, sir, I can see you through my monitor, sir.
Yeah, I got it. You have a different screen in front of you. The same Zoom classes you are seeing in front of in a different monitor, right? That's why I see you in a different direction. I understand it. So, Kaushal, what do you think? In the case of a concave mirror, how will we mention it? How will we give the features, or how will we identify it without touching it?
Without touching it, sir.
Yes.
The properties.
Yes.
So without touching it.
If we touch it, we'll know the physical appearance, curved inwards and all, right?
Will be magnified, erect, and the distance between the object and the mirror, it'll be reduced, I guess.
Reduced? In the case of concave mirror, if the image is of larger size and erect and changes to inverted and smaller size by changing the position of the mirror from the object, it is concave.
Oh, yes, sir.
Got it? So,
Okay, sir.
we have learned, in the case of a concave mirror, we have learned an exceptional case, right? What was that? The object is kept between P and F, which means the object is kept very close, right? The object, if we are keeping the object, very close, that is very close to the pole and the focus. If you're keeping the object very close to the, if you're keeping the object very close to the pole and the focus, okay? So in this case, what we'll be getting an enlarged image. So when we're keeping the object away from it, if we're keeping the distance away from it, the size of it gets diminished eventually, right? So that is the case in the case of a concave mirror. So who gave answer before it? Ulrich gave a good try. The size of it will be larger and erect, but only in the case if the object is kept between the focus and the pole. And eventually, if we are changing the position, what will happen? The image will get inverted and smaller in size. So if in that case, we can figure out it is concave mirror. If the image is of larger size and erect and changes to inverted and smaller size by changing the position of the mirror from the object, in this case it will be a concave mirror. Everyone nod your head only if you got the concept. Understood why? In the case of a concave mirror image formation, we have learned it, right? Only in the last case when the object was closer to the pole. In that case we got an enlarged image and it was erect as well. But in the next case, when we are keeping the object away from the mirror, what is happening? We are getting a diminished or smaller size. And what is happening? It will be inverted. The image will be inverted. So if you know all these features, we can identify concave mirror without touching it. Fine. So I gave you two answers. So based on it, who will be answering me? The case of convex mirror, easiest. Convex mirror is the easiest. The case of concave mirror, we'll have confusions. Two cases are there. One case will have a larger and erect image, and we'll have in the latest stage when we are changing the position, we'll get inverted and smaller sized images. But in the case of a convex mirror, what we'll do?
Alina, did you?
Yes, Alina Dibin.
Yes, sir. So the image will be diminished no matter the position.
Image will be diminished, and in the case of convex mirror, what will happen? What will be its features or properties? What do you think? So someone has hand raised, it's okay? Yeah, it's okay, it's okay. Good try. So unmute, someone has hand raised, Jayasudha man. Yes, please. Yes. Manish, right? Very good, Manish. Manish is like, sir, I will answer. Yes, Manish, go ahead.
Then it will be highly enlarged and virtual and erect.
We'll get a highly enlarged, virtual and erect image. So, Manish, are you sure in the case of a convex mirror, always we will get virtual and erect images? Sure?
Yes, ma'am. Yes, sir. Sorry.
Okay, fine. So, Manish, what do you think? The size will be always enlarged? In case of convex mirrors?
Highly enlarged or enlarged.
The size will be always enlarged or what? Oh God. Oh God. Ouch. If the image is smaller, got it, not enlarged, okay? The image is smaller and erect for all positions of the mirror from the object. It is none other than a convex mirror. Got it, Manish? So you gave the perfect answer. It's just that the size of it you were confused, enlarged or diminished. So size will be smaller, but obviously the nature will be erect for sure. Very good, fine. So if the image is smaller and erect for all position of the mirror from the object, it is a convex mirror. So if you know all these properties, or if you remember these features, you can figure out the mirrors without touching them. So you can't say whether it is curved inwards or outwards by looking at them. If it's kept away, you won't be able to figure it out, right?
Sir Rihan, I am not clear about the concave mirror.
Yes, unmute Rihan. Hand raise, Rihan, where are you? Yes. So Rihan, are you there listening? Unmute yourself.
Yes,
So Rihan, in the case of a concave mirror, how many cases we have? 6 cases, right?
yeah.
Can you see over here 6 cases? These are the image formation in the case of concave mirror, not convex, sorry, concave. Okay, Rihan? So, in the first case, the position of the object was at infinity, right? So imagine I'm considering a concave mirror. Okay, imagine I'm considering a concave mirror. So in the first case, the object was kept at infinity. Okay, imagine this is infinity and this is the object. So in the first case, I'll get the image at f. So the image will be, what will happen? The image will be focused over here, right? Yeah. So I'll get a real and inverted and highly diminished image. Okay, got it? So Rihan, as we come closer, if I am keeping the object beyond C, imagine this is C and this is F. So if I am keeping the object beyond C, I am getting the image between C and F. So as I come closer, what is happening? The image formation, okay, image formation is getting away, right? At F, between C and F, at C, beyond C, and at infinity. And the last case, only in the last case, when the object is kept between P and F, we'll get the image behind the mirror. Okay? Only in this case, I'm getting the image behind the mirror. Now, what is mentioned in the case of concave mirror? What is mentioned over here? If the image is of larger size and erect and changes to inverted and smaller size by changing the position of the mirror from the object, it is concave mirror. So, over here, from the example, you can see that In this case, there is between P and F. In which case we'll have between P and F. So if you're keeping the object between P and F. In this case, where we'll get the image, behind the mirror, virtual and erect.
Sir, President is
Isn't it?
asking for a
Yeah, wait a second.
Okay.
So Rihan, so when I'm changing the position of the object, when I'm keeping it at infinity or beyond C or between C and F, in all these cases, I'll get the image over here, right? Inverted images, right? And I'm keeping the object at C and all, we'll get the inverted image beyond C at infinity. In all these cases, I'm getting the image inverted, right, Rihan? And the size of it will be diminished. So only in the first case we'll get the enlarged and erect image. So that is why it is mentioned in the case of concave mirror. So the image formed will be enlarged and erect as we keep changing the position of the object. Over here, can you see when we are changing the position of the object? Can you see when we are changing the position of the object, we are getting the image inverted and real. Got it? Only in this case we are getting the virtual and erect image. So that is mentioned in words over here. If the image is of larger size and erect and changes to inverted and smaller size, how will it change to inverted and smaller size? When we are changing the position, right? When I'm keeping the object from between F and P to between C and F or beyond C or at infinity, when I'm changing the position of the object, the image formation will also change, right? Got it, Rihan? Understood it? Still confused or what?
No.
Clear? Fine. So please do unmute. Who was that? Prajna. So Prajna, please do raise your hand. Prajna, where are you? Yes, Prajna. What's your question?
No, I just, you were asking a question earlier, so I just wanted you to repeat the question, but it was the same question.
Yeah, it was the same question. I was just explaining this particular second point. Got it? So do you have any confusions in any of these points? No, right? Give me a thumbs up if it's clear. Fine. So if the image is smaller and erect for all positions of the mirror from the object, it will be a convex mirror. I hope you guys know it. In the case of a convex mirror, we have learned it. Always the nature of the image will be virtual and erect, and the size of it will be smaller or diminished or highly diminished. Got it, guys? Clear? So you are just applying the properties or the features of it. Now, draw the following diagram. Guys, if you want to note it down, please do note it down real quick. So once you're done noting it down, give me a thumbs up, then only I'll come back. In the meantime, Rahul sir will be making me invisible. Today we have Rahul sir to support us. So host, yes Rahul sir. Once you're done, type done in the chat box, sir, done writing. Then only I'll come back. Yes, there we go. Guys, everyone done? Should I come back or what? So everyone is like, no sir, please stay over there, we don't want to see you. We are not writing over here. So I can see the question of the diagram. There is no diagram, right? This was the previous query, I guess. Yeah. So here there is no particular diagram required. So guys, everyone done or what? Give me a thumbs up, then only I'll come back. I guess no one wants me to come back, right? So please stay over there. We don't want the session or what? Fine. So everyone is giving me thumbs up. Yes, Rahul sir. There we go. Everyone done? Can we go ahead? Happy or what? Not happy? Not happy, sir. Please don't come back. You can stay invisible, right? Rihan, understood all the 3 points? Clear? Rihan, are you there? Rihan P. Shahjahan, are you listening? All the 3 points clear? Any confusions?
Sorry, no?
All the 3 points clear? No confusions?
Confusion, yeah, clear.
Yeah. Unmute Sridhaya. Sridhaya, right?
Sridhya.
Sridhya. Yes, Sridhya. What's your confusion? What's your query?
Sir, that justify question, they said to draw also, right?
Yes. You're asking about this particular question, right?
Yes, sir.
Yes. The ray diagram of a convex mirror. We have learned it in the previous session already. Do you remember? All the ray diagrams in these 2 cases.
So anything is fine, right? Any
Yeah. At infinity or between infinity or power, any particular diagram you can draw. One single diagram is fair enough. Because in both the cases, we will get the virtual and erect image, and somehow always the size of it will be smaller or diminished. Clear, Sridhya? Yeah.
Yeah, so and that the description, whatever it is.
Yeah. Convex mirror will be a convex mirror since we are getting the virtual and erect image. The size will be diminished. Got it, Sridhya? Why you didn't ask it that time when I was discussing that particular question? Sorry, I forgot or what?
No, that's whether you didn't see the chat.
Okay, fine. So, anyways, that right away you can raise your hands if I'm not checking out, if I have missed your question in the chat box, guys. Everyone, not just Sridhya. If you feel like, okay, sir, I have missed my question in the chat box, you can raise your hands. You can ask me directly. So, guys, everyone done, right? Can we go ahead? Fine. So, this particular question, draw the following diagram in which a ray of light is incident on a concave or a convex mirror on your answer sheet. So imagine if it's incidenting in the first case this is a concave mirror, right? So these 2 cases it is a convex mirror. So if the light rays are incidenting like this, how will it reflect back? You have learned some rules, right? If the incident ray is passing through the focus, if the incident rays appear to pass through the focus, if the incident ray is passing or incidenting the pole. So in all these cases, how will it reflect back? We have learned some rules, right? So based on that, what you have to do? You have to draw the ray diagram. Okay, you have to draw the reflected rays. So this particular question, yes. So this particular question was asked in Cbse 2016. This was a previous year question, important. So unmute Manish. Yes, Manish, what's your concern?
Sir, I just want to answer the questions.
Okay, so Manish, what you have to do is wait for a second, let everyone draw it. So get it ready in your notebook and show it to the camera once you're ready, once you're done. Yeah, all the three reflected rays. Then I'll call your name.
Sir, Anshi Sanders.
Yes, Anshi.
Ansh.
Right? Hi Ansh.
Yes.
So before we go, how should I pronounce your name? Come again? How should I pronounce your name? Ansh, right? Ansh?
Okay, sir. So, Ansh.
Yeah, Ansh. So Ansh, what's your question? What's your query?
Yes, sir, I just wanted to answer the question.
You just want to answer. So are you done drawing it in your notebook?
I am drawing it. Okay.
Yeah. Draw it right away, real quick. Yes, you can mute yourself, then I'll call your name. So before we go, who was that previously? I gave you an imposition, right? Who was that, ma'am? Yes, I gave an imposition, right? Concave mirror, convergent mirror. Can you please minimize the chat boxes? Yes, Jaswin. Unmute Jaswin. Yes, on top, ma'am, hand raised. Yes. Jaswin, keep it close to the camera. Jaswin is like very polite. Yes, sir, I've done it. Concave mirror, convergent. Okay. Jaswin, will you make a mistake again?
No.
No, right? So very good, Jasmine. I hope you have learned it. It's not like okay, I've written the imposition. No, it's just for you to remember it. Okay, it's something very useful for you. Okay, you'll be using it for your exams. So if the concave mirror is convergent, what about the convex mirror, Jasmine?
Diversion.
Will be divergent, right? So please do remember it, don't forget. Okay, so use it for your exams. So you'll be like, yeah, I know it already, I'm thorough with it, I've written the imposition. So guys, don't take it like okay, I got imposition very bad. No, you're just learning it in a better way. That's it. Very good, Jasmine. So guys, once you're done with this particular ray diagram, let me know. Fine. So we'll ask Ansh itself, right? Then we'll go to Manish. Yes, Ansh, unmute yourself. So Ansh, the first case, we are having the concave mirror, right? We are having concave mirror. Okay. Then how will we have the reflected ray? If the incident ray is passing through the principal focus like this, how will we get the reflected ray?
Yeah, so it will be parallel to the principal axis.
It will be passing parallel to the principal axis, right? Why? Why?
So why?
What is the reason for it? There is a particular rule. If the incident ray is passing through the principal focus, it will reflect back. We have learned some rules, right? If the incident ray is passing through the principal focus, it will reflect back parallel to the principal axis. There is a particular rule, right? Got it, Ansh?
Yes, sir.
Yes, very
Yes,
good. Very good. Now let's unmute Manish. Hi, Manish. Yes, Rahul sir, please do take down this name tab. Yes, Manish. In the second case, if you are having a one second. If you are having a convex mirror, okay. So Manish, this is supposed to be a convex mirror, okay, not a half-boiled egg. So here we have the incident ray of light, which appeared to pass through the principal focus. Yes, Rahul sir, please. Yeah. If it appears to pass through the principal focus, what will happen? How will it reflect back? Like
45 degree angle.
45 degree and all. In the case of a convex mirror, if the incident ray appeared to pass through the principal focus, how will it reflect? So in the first case, we have learned if the incident ray is passing through the principal focus, it will reflect back parallel to the principal axis. Then in this case, Manish is confused, sir. I was about to answer, now I got confused, isn't it? So Regin will be helping me out. Yes, Regin, are you there? Yes, Joel, I'll call your name. Joel, keep your hands raised. I'll call your name. Yes, Regin.
Yes, sir.
So Regin, what do you think? If the incident ray ray appear to pass through the principal focus, how will we get the reflected ray?
So, when the incident ray is passing, appears to pass through the focus, we'll get the reflected ray, which is parallel to the principal axis.
The reflected ray will be parallel to the principal axis, right? The reflected ray, if we have the incident ray which appear to pass through the principal focus, what will happen? The reflected ray will be parallel to the principal axis. Got it? Yeah. So now, yes guys, you don't have to draw this diagram. I'll be giving you the beautiful diagrams. The diagram which I'm drawing is very beautiful, I know it. Just for your understanding, I'm drawing it. So for you to note it down in your notebook, I'll be showing the proper diagrams. So it's just for your reference. Yes, unmute Joel.
Sir, 1 minute. Mukta is asking.
Mugdha, what is the answer? Yes, this is the answer. The incident ray the reflected ray will be passing parallel to the principal axis. Okay? The angle of incidence will be equal to the angle of reflection. If we are considering a normal, obviously the angle of incidence and angle of reflection will be equal. So over here we don't have to consider that, right? Yes. Unmute Joel.
Yes, sir.
In the
So
third
mirror
case,
also will be
in the third
the
case, if we're
reflected ray will
considering,
be
yeah, if we're considering a convex mirror like this, and the incident ray is incidenting the pole,
yeah, the reflected ray will be equal to the incident ray.
it will be equal to the incident ray with respect to the principal axis, right?
The rules
Yeah.
principally happens to axis.
Yeah, with respect to the principal axis, the reflected ray will make the same angle, right? With respect to the principal axis, it will be making the same angle if the incident ray is incidenting to the pole. Guys, this is supposed to be the pole P. Okay? So anyways, I guess you got the concept, so I'll be showing you the proper ray diagrams. In the first case, we'll have the reflected ray parallel to the principal axis. Guys, can you see over here? It is parallel to the principal axis, right? Then the next case, the reflected ray is also parallel to the principal axis. Why? Since the incident ray appeared to pass through the focus. Then in the next case, if it's incidenting to the ball, it will be making the same angle with respect to the principal axis. So based on the rules in the case of image formation, in the case of convex mirror and concave mirror, when we are applying the rules, we'll get the reflected rays like this, as you see over here. Yes. Now, who had a query? No one, right? Any queries, anyone? Confusions? How did we get the reflected ray like this? Why is it not going the other way? So if you have any confusions, please do let me know. Ritika, unmute Ritika. Ritika,
Yes,
is
sir.
it clear?
Yes, sir, it's clear.
Yeah. So why are we getting the reflected ray like this in the second case, second diagram?
So because it's a convex mirror.
Because it's a convex mirror. Then, based on the rules of image formation in the case of a convex mirror, if the incident ray of light appeared to pass through the principal focus, obviously it will reflect back parallel to the principal axis. Yeah. So convex mirror, do you remember? If the incident ray appeared to pass through the principal focus, can you see over here? It will pass, it will reflect back parallel to the principal axis. Got it? So here is the other way. So in this case, can you see? If the incident ray is incidenting or appear to pass through the principal focus, it will reflect back parallel to the principal axis. So this is the other way. When the incident ray is parallel to the principal axis, it will appear to pass through the principal focus, or it will reflect like this. So this is the case which we were learning. So in that particular diagram, this particular incident ray was given, which appeared to pass through the principal focus. So the reflected ray will reflect back parallel to the principal axis, as you see here. So this is based on the rules. Remember, there is rules for studying the image formation in the case of a convex mirror. So this was an example for it. Guys, please do draw the ray diagrams. Please do let me know if you have any confusions. Real quick, draw the ray diagrams, everyone. Let me know if you have any queries, concerns with the ray diagrams and all. Please do let me know real quick. Once you're done, let me know. Regin, you have a query or you forgot to lower it? No queries, right? Unmute Regin. Yes, Regin.
So, yes, there's just one doubt. In the third diagram, right, this third one, isn't necessary that we need to write like angle I is equal to angle R, like incident angle is equal to.
No, it is the rule we are applying directly, right? If you are learning the rule, you have to mark the angle of incidence and angle of reflection will be equal with respect to the normal, that is the principal axis in this case. Got it? So in this case, what are we doing? We are just applying the rules directly. So we just have to draw the reflected ray. Got it? Yeah. So if you feel like, okay, if for a better clarity, it'll be better if you're marking the pole over here. So it'll be better if you are able to, if you can mark the pole over here. Yes. Yes, the man.
And she's asking a question.
So will there be rules in word format in board exams? No. You just have to apply the rules. That's it. In word format, it will not be there. Don't worry. Yes, Sridhya. Unmute yourself.
Sir, so for this Pentagon and all, the angle should be correct, right?
Yeah, the
The
angle should
same
be
angle.
perfect. Yeah, these two angles should be the same.
Somehow, almost same is okay. And then
Yeah,
the
you don't
path
have to
and
use the protractor and all, not required. It's just that it should look the same. It should not be like the incident ray is coming like this and the reflected ray like this. Big differences should not be there. Got it?
Okay.
Yeah.
Okay.
Guys, once you're done, please do let me know. Fleck parallel to the principal axis. Yes, some of you have answered in the chat box. Very good. Done, everyone. The ray diagrams. Okay, those who are done, what do you have to do? Show your notebook to the camera. Let me see the ray diagram. Show the ray diagrams to the camera. Let me see. Everyone. I don't want to see anyone's face. Everyone, cover the camera with your notebook. Quick. Not like, okay, close to the camera. I'll cover the camera. No. I want to see the ray diagram. Quick. Dhruv, where's your notebook? Dhruv, Dilip. Close to the camera. I can't see the ray diagram. Dhruv, Dilip. Top of it. Yes. Chris John. Where's your ray diagram? Chris John. Unmute Chris John. Chris John Anthony, right?
Yes.
Yes, Chris John, where's your ray diagram? Unmute yourself. So, Jessida ma'am, please note Chris John Anthony.
Yes, sir. Sure.
Yes, Chris John Anthony will be getting a call. Anyways, your parents will be informed, or else you can unmute yourself or let me know what's your concern. Or else you'll get a call from our admin team to your parents. So your parents will be answerable where Chris John went from the session or ran away or what. Chris John, where's your ray diagram? Show your notebook to the camera. Quick, or type your concern in the chat box. Or unmute yourself. Raise your hand. So guys, everyone done, right? Just the one, please note Chris John Anthony. Done, right?
Yes.
So guys, let's go ahead. Consider the following diagram in which M is a mirror and P is an object and Q is its magnified image formed by the mirror. State the type of the mirror M and one characteristic property of the imaged Q. Easy, right? Very easy. If you're keeping the object between the pole and the focus, or between the mirror and the focus, if you're keeping the object over there, and if we are getting the image behind the mirror, that is enlarged and erect image, what type of mirror will be? And one characteristic property, easy, right? Will be the easiest question I would ever ask. So please do unmute. Who was that? Over here, hand raised.
Manish.
Okay. Okay, I will give a chance to
Sridhya.
okay. Sridhya. Okay. So Manish and Sridhya, Mohammed, Ishan, a lot of you are hand raising. Yes, Sridhya, what do you think?
It will be concave mirror.
It will be a concave mirror, sure.
It will.
So now Sridhya is thinking, oh god, my answer went wrong or what? We'll check it. So Sridhya says that it will be a concave mirror. Unmute Mohammed Ishan. Mohammed Ishan, what do you think? Will it be a concave mirror or a convex mirror? Mohammed Ishan.
Sir, it is a convex mirror.
It will be a convex mirror.
Yes, sir.
So in the case of a convex mirror, will we get an enlarged image compared to the object? Over here, it is mentioned P is the object, right?
It is concave mirror.
Yeah, who was that? Sridhya says that it is concave mirror. Yes, Sridhya, it's okay, you can mute yourself. So I have registered your answer. Sridhya said concave. We'll check the answer. Yes, unmute. Who was that? Ansh. Yes, Ansh. Ansh, what do you think? Concave mirror or a convex mirror?
Sir, it's a concave mirror.
It's a concave mirror. What do you say? It's a concave mirror. I need an explanation.
Sir, according to the rule, if it's between P and F,
According to the image formation, in the case of a concave mirror, if the object is between P and F, what will happen?
sir, then the object will be formed. Sorry, then the
Object will be
behind
formed.
the mirror. Sorry, the image
The image will be formed where?
behind the mirror.
The image will be formed behind the mirror. What about its size? It will be smaller or enlarged?
Its size. No,
Rijin is like, sir, please call me. Rijin will be telling me.
I'm not sure.
I'm not sure. Over here from the diagram itself, you can see the size of the image compared to that of the object. Yes. And mute. Haripriya. Haripriya left on top. Yes. Haripriya,
Yes, sir.
what about the size of the image?
It's an enlarged image.
It will be an enlarged image. So what type of mirror is it? Convex mirror, right?
No, it's a concave mirror because center curvature and the focus is at the left side of the.
So the left side. In case of convex mirror also it will be on the left side, right? The in front of the mirror will be considering it on the left side itself.
Yes, but according to the rules of the image.
According to the image formation, we won't get an enlarged image in the case of a convex mirror, right? The case of a convex mirror always it will be diminished image, right?
Yeah.
Yes, very good. So unmute Rijin. Yes, Rijin. What about the size of it? We'll get diminished image or enlarged image?
So since it's a concave mirror, then
Since it's a concave mirror, yes,
the image will be enlarged.
the image will be enlarged, right? So what is this case? The first case of the concave mirror, right? From the table which we learned.
Sir, this is the case like where.
This is the last exceptional case where we learn. Only in this case we'll get a virtual and erect image that is behind the mirror, right? Do you remember, Regin?
Yes, sir.
Fine. So very good. So in this case, it is none other than a concave mirror. Yes, Manish will be letting me know. State one characteristic property of the image Q. Manish. Yes, Manish. One characteristic property of the image Q over here.
It'll be highly enlarged image.
Enlarged, not highly enlarged. It will be enlarged, right? It will be highly enlarged. Okay. So Manish is saying we'll get a highly enlarged image. And what about the nature of it? Size you told highly enlarged.
Nature, it will be virtual and erect.
It will be virtual and erect. Fine. We'll check it. So in the last case, we'll get the size of the image as enlarged and the nature of the image will be virtual and erect. This is the case in the case of concave mirror. If the object is kept between P and F, we'll get the image behind the mirror and the nature of it will be virtual and erect and the size of it will be enlarged.
Sir,
So-
Aswati is asking aloud.
So will there be a mark for the diagram even though the diagram drawing was wrong? No. If it's wrong, obviously you won't get the answer. You won't get marks. Anyways. So guys, if you are asking about the diagram for this is the diagram. If you are keeping the object between P and F, we will get the image behind the mirror like this. So this is the ray diagram. We have learned about it already. So you don't have to draw it right now. So in this particular case, the image will be the object, the type of the mirror will be a concave mirror. It will be a concave mirror, and one characteristic property that is you can write as the image form will be enlarged, virtual, and erect. Virtual and erect. This is the answer you have to write for this particular question. So if the object is P and the image is Q, so what will be? Say the type of the mirror M. The type of the mirror M is none other than a concave mirror. And what about it? What about one characteristic property? Enlarged, virtual, and erect. Yes. And mute. Who was that? Just type it down. Who has hand raised? Those who are hand raised? Roshni, right? Roshni, type your answer in the chat box. No queries, right? No queries, or you have a query?
No.
Fine, fine. So guys, I hope you are done with this question. So those who didn't write the question, write down real quick. Important. This was also a previous year question. Please do write it down. Quick. For the time being, should we go ahead with the screenshot? Or you'll be writing it? You'll be writing it, right? Fine. Once you're done, please do let me know, guys. Once you're done. Please don't forget to draw this diagram as well. And don't draw a concave mirror directly. Just draw this like this. Mark it as M, P, Q and all. And in the next image as an answer, you can draw a concave mirror. Keep the object between F and P or F and the mirror. And what you have to do, draw the image behind the mirror like this. That is in the position of Q. And mark it. And you can write the answer as concave mirror, and the property, one single property you can write as enlarged vertical and erect image. So then the question was asked, right? One characteristic property of the image Q.
Mugir is asking about the exam session.
Yes, exam session we will have it. Don't worry. Don't worry.
Also one more question.
So will we learn about magnification? Yes, magnification. We'll learn about it. Don't worry. We'll have the Cartesian sign convention coming up. Then we will learn about the mirror equation. So during that time we will learn about the magnification properties in the case of lenses and all. Yes, lens is there. We are only in the first part of the chapter, light. This is reflection, right? So when we go ahead with the concept of refraction, we'll be learning about lenses. Yes, Mohammad Ishan, you want to answer or you have a query? Forgot to lower your hand or what? Mohammad Ishan.
Sir, I have a doubt.
Yes, go ahead.
Sir, how did a concave mirror as the image formed is behind the mirror?
In the case of a concave mirror, we have learned an exceptional case, right? Only in the case where we are keeping the object between F and P. Okay? Only in this case, when we are keeping the object between F and P, we'll get the image behind the mirror. Why? Because the object is so close to the mirror. In this case, is there a particular space to form the image in front of the mirror itself? Not possible, right? Can you see over here with respect to the angles and all? Is it possible? No, right? Even though this in such incident rays will reflect, will it be possible to form an image over here? No, right? No, right? So what we'll be doing, we'll be considering, imagine we are considering two rays like this. So one ray will reflect back like this, right? Inwards. And we'll have this projection, right? And this particular ray will reflect like this and we'll have its projection like this, right? So like this we'll get the image. So this is the proper ray diagram if you need it. So this incident ray will reflect back like this to the principal focus. So we are keeping the object between P and F, right? Not at F. So this particular reflected ray will go like this, and this particular reflected ray will go like this. So will it be possible to form an image over here? No, right? So we'll get the image behind the mirror. We'll get an imaginary image behind the mirror. Got it, Mohammad Ishan? If you look at the ray diagram, you can see the reflected rays are diverging according to its wish. Even though the rays are converging, over here you can see, right? With respect to the rules, if we apply the rules, what is happening? They are reflecting away. So only we can get the image behind the mirror. This is the only exceptional case. In the case of concave mirror, we are getting the image behind the mirror. Clear, Mohammad Ishan?
Yes, sir.
Yeah. And mute Sridhya. Yes, Sridhya, what's your concern? You forgot to lower your hands or what?
No, sir, I have a concern.
Yes, go ahead.
Like, yeah, in our school, the chapter is electricity.
Yeah.
Electricity, and then one eye chapter.
Human eye and colorful world.
So those two are the chapters which is there for this first term exam.
Okay.
Only for the second term, this chapter is coming for us.
Okay. So the thing is, we are going according to the syllabi. With respect to your syllabi, this is the first chapter in physics coming up. This is chapter 10, right? So human eye and colorful world is the 11th chapter, electricity is the 12th chapter, magnetic effects are the 13th chapter. So we're going in that particular pattern. Got it? We're just taking it in a general term. Okay? Generally, when we have checked out in most of the schools, this particular chapter, light is started already. Got it, Sridhya? So we are taking the majority. Hope you understand. Got it? So we are going in that particular pattern, chapter 10, chapter 11, chapter 12, 13. Got it? So guys, clear? This particular question, I hope everyone is done with it. So let's go ahead with the exam session. Yes. So over there in the web page or the app itself, you'll have an option or a tab down there, right? So in that particular section, if you click on it, you'll get an option to fill out the answers. Everyone is like, sir, exam time, the time is up. You're gonna go ahead and all right. Don't worry, please do submit your responses. Yes, lens is there. Some of you are asking, sir, is lens there? Yes, lens is there. When we learn about the concepts of refraction, we'll go ahead the lens. Sir, will we have test now? Yes, we have a test right now. Right away, click on the link. Not the Google form link. You'll be having a link or a tab in the app itself or in the web page itself. On your login page. So just below your Zoom link, you'll have a tab to attend the exam session. So guys, don't worry. It's not something very complex with respect to the concept we are going to learn. All those questions are based on the image formation with respect to the plane mirror, with respect to the concave mirror and all. Very easy, easiest 5 questions. Okay, submit your answers. Don't forget to do it. Very, very important. So everyone is thinking, oh God, the time is up. Don't worry, we'll be checking out the answers in the next session. Or else if I rush and give you all the answers, everyone will be thinking, okay, we'll submit their answers accordingly, right? The Zoom meeting will be minimized over there and you can click the right answers. No. I'll be discussing the quiz answers in the next session, not right now. So please do submit your answers real quick. So only when you're done, I'm going away. Or else I'll be staying here. Okay, fine. Please do go ahead with the exam time. No. So once you're done, type down in the chat box. Those who are done, type down in the chat box. Let me see how many of you are submitting the responses real quick. Done, everyone? Done? Okay. Done. Everyone done from everyone. Many done should come. Okay, 10 on 10. Some of you are saying 8 on 10, 10 on 10. Sir. Who is calling sir? Reem Sheikh. Yes, Reem Sheikh. Unmute yourself. Hand raise, Reem Sheikh. Where are you? I can't see you. Raise your hand. Reem Sheikh. Yes. Unmute yourself, Reem Sheikh.
Yes, sir.
What's your concern? Why, sir? I'm not running away.
Sir, I'm done and I got 10 on 10, that's all.
Okay, so Reem Sheikh is like, yeah, I got 10 on 10. I'm so excited, happy. So you just want to share that, right? Questions were easy, right? Easiest 5 questions, isn't it? So Reem Sheikh muted or what? Reem Sheikh, what do you think? Should we discuss the answers right away or in the next session?
Right away.
Right away we can discuss the answers, right? So what do you think, guys?
So we can go in.
Okay. Yes, done. Done 6 on 10. So what you have to do is, we are not going to discuss all the 5 questions in detail. We have to discuss because with respect to the image formation of a concave mirror, plane mirror and all. So the question very easy, but I did it quick. So I made some wrong. You have to think well and do it right. It's just that you have time limit. If you can't give 1 hour for 5 questions, no, maximum 5 minutes. So guys, anyways, we have to discuss all the 5 questions in detail. So that is why I'm not taking it ahead. So right away, when I give you the answers, you'll be submitting the responses now, right? So it's better. What I'll do is, I'll be discussing the questions in the next session. So we'll be discussing not just the question, the answers as well. So based on that, we'll discuss the concepts as well, so that you'll have a better clarity. Okay, so let the answers be a suspense. So those who got 10 on 10 are like, okay, we don't know the answers, we know it already, right? So if you're not answering in the next session, okay, impositions are coming your way, guys. It is very important. It's not something. I'll be very friendly to you guys. I'll be giving you time to write. I'll be giving you all extra support. Even if you ask any particular query or concerns, or for all those things, I'm supportive, right? Why? Expect my students to learn it. If you're not doing it, I'll not be supporting you guys. I'll be like, okay, learn it in your own way. So guys, it's mandatory. Please revise all the concepts which we learned today. Got it? Important, not just today, all the concepts which we learned till now. So if you have understood all the portions which we discussed today, give me a double thumbs up to the camera, everyone. Let me see a double thumbs up to the camera. Fine, everyone is like, yeah, we are gonna wind up, right? Energetic, fine. So when we are gonna wind up, everyone is energetic. No, right? Fine. So anyways, that's all for today, guys. Thank you and have a nice day. Bye.